Hello, my name is Jung, and I'll be presenting my Capstone project on the human gut microbiome and the rising incidence of early onset colorectal cancer. In 2021, the U.S. Preventive Services Task Force lowered the age recommendation for CRC screening from 50 to 45 based on the growing trend of colorectal cancer among younger populations. Diagnosis with CRC for those younger than 50 is referred to as early onset CRC, while CRC diagnosis for ages 50 and older are referred to as late onset CRC. A majority of the early onset cases are sporadic, and the genetic mutations alone cannot realistically explain for this rise in incidence in a short time period. Due to a myriad of factors, researchers have proposed that changes to the existing risk factors of CRC, such as obesity, notably from the globalization of Western diets, may have somehow put younger people at a higher risk of CRC. The gut microbiome is implicated in both CRC risk and obesity. Current literature on the gut microbiome and CRC association mainly focuses on late onset CRC only. Therefore, it is still unknown as to how and whether the gut microbiome is implicated in the rise of early onset CRC. Specifically, there is still a lack of agreement on whether the gut microbiome of early onset CRC is different from late onset CRC. In this study, we sought to closely investigate the role of the gut microbiome in the association between CRC and obesity, our chosen modifiable CRC risk factor measured by BMI. We conducted a mediation analysis hypothesizing that BMI affects CRC risk through the gut microbiome. Due to the dearth of metagenomic data on early onset CRC, we conducted this analysis on a sample with majority late onset CRC in order to explore this relationship as our first step. Our second hypothesis was that the gut microbiota of early onset and late onset CRC are distinct in a way there will be divergence between the biomarkers of the two groups. We first identified CRC studies with metagenomic data saved in the curated metagenomic data package in R. This resulted in 11 studies that used similar DNA extraction and sequencing methods. Their metagenomic datasets were pulled together along with the clinical data available. In our exploratory data step, alpha diversity, referring to the degree of microbial species diversity, was contrasted on CRC status and obesity status. Then the actual mediation analysis was performed using linear and logistic regression models to calculate the average causal mediation effect using the mediation R package. In order to identify microbial species that were enriched among early onset CRC cases and late onset CRC cases separately, differential abundance analysis was conducted on each subset using the DSeq-R package. This generated two lists on enriched microbial species for each group, which were then ranked based on their p-values from the order of most significant to least significant. Finally, the degree of concordance between these two lists were plotted. Any species that was enriched in the early onset group but not in the late onset group was noted as a potential biomarker for early onset CRC. In the full sample, including datasets from all 11 studies, the control group was younger than the CRC group with a statistically significant t-test p-value. There were more males than females in both groups with a statistically significant chi-square p-value. BMI and obesity status with a cutoff at 30 kilograms per meter squared was not significantly different between the controls and CRC as outlined in red on this slide. This was a problem we encountered since BMI was our primary exposure of interest. Upon further investigation, we discovered that 2 of the 11 studies had controls matched on BMI. So upon excluding data from those 2 studies, BMI was significantly higher among the CRC group, but obesity status was still the same between the control and CRC group. Therefore, we chose the numerical BMI variable instead of the binary obesity status variable for downstream analysis. Using the sample excluding data from the 2 BMI matched studies, alpha diversity was measured using the Shannon Diversity Index, and we found that the Shannon Diversity Index decreased from controls to CRC, and this change was statistically significant with the Wilcoxon rank sum test p-value less than 0.05. On the other hand, alpha diversity was similar between lean and obese individuals. From this, we suspected a weak association between BMI status and alpha diversity. In preparation for the mediation analysis, a linear model measuring the mean of the Shannon index based on BMI was constructed and confirmed the null association between BMI and Shannon Diversity Index. Despite this, we conducted the mediation analysis using this linear model along with the full logistic regression model, where CRC status was regressed on BMI and Shannon Diversity Index, adjusted for age, sex, and study. As expected, our results were in opposition to our hypothesis because the average causal mediation effect was 0, meaning no mediating effect by alpha diversity was observed on the association between BMI and CRC. Based on our results, the mediating or indirect effect is equal to 0.001, and the p-value is greater than 0.05, and the 95% confidence interval contains 0. Moving on to the results of our secondary analysis, this slide contains the concordance at the top plot, demonstrating that upon comparing the overlap of the two ranked lists of microbial species enriched in the early onset CRC group and the late onset CRC group, there was significant overlap at the top 6 ranked taxa between the two groups. This p-concordance is shown by the solid line falling outside of the 95% confidence intervals generated at each rank when concordance was measured repeatedly 100 times, randomizing the lists each time. P-concordance of 0.67 was observed at the 6th ranked taxa, with 3 shared microbial species up to that rank. One of the top 6 microbial species, Streptococcus gordani, was enriched in the early onset CRC group, but not enriched in the late onset CRC group. When the prevalence of Streptococcus gordani was compared between younger controls and the early onset CRC group, and also between the older controls and late onset CRC group, we observed that this species was significantly more prevalent among the early onset group than the younger controls, whereas the late onset CRC group and older controls had similar prevalence. One theory for this is that Streptococcus gordani is normally uncommon in younger individuals, but young people with CRC may have increased abundance of this species. This species is associated with dental plaques and also a rare cause of endocarditis in the current literature. In conclusion, we found that the gut microbiome and obesity measured by alpha diversity and BMI respectively were weakly associated, and no mediating effect of the gut microbiome was observed from the alpha diversity perspective. However, our results support previous studies that have also observed increased CRC risk with gut dysbiosis and obesity. Other ways of measuring the gut microbiome as a mediator may be of interest in understanding the causal direction between certain exposures and colorectal cancer. Next, we postulate that there is divergence between the early onset and late onset microbiota at the microbial species level, and should consider a more focused exploration of early onset CRC gut microbiome in future studies. Streptococcus gordani, for example, may be a biomarker for early onset CRC but not late onset CRC. Overall, our study advocates for further research on the causes of the rise of early onset CRC incidence in relation to the growing evidence supporting the important role of the gut microbiome and CRC.